Hey everyone, in this video I'm going to teach the applications of direct variation, not of inverse variation because we haven't done that yet. Inverse variation actually is a relationship whereas one variable increases, the other one decreases, and we won't do inverse variation until second semester when we talk about rational expressions. So right now we are focusing on relationships of direct variation. Situations whereas one variable increases, the other one increases. Like when you are babysitting, the more hours you babysit, the more money you make. So let's take a look at these problems. The sales at a baseball game varies directly with the number of people attending. If the sales for a game are 12,000 when 800 people attend, determine how many people attend if the sales are 15,000. First, you want to note that sales varies directly with number of people attending. So the fact that it says varies directly means that sales and number of people follow a y equals kx relationship. Sales is y and number of people is x because sales is dependent on the number of people that attend. So the first thing we want to do is we want to find k. And they told us that when 800 people attend, the sales are $12,000. And that is the ordered pair 800, 12,000. Because 800 is people and 12,000 is sales. K is equal, or your slope is equal to y over x. Oops, my x is 800. So y over 800. And I know that because they said that the relationship varies directly. 12,000 divided by 800 is 15. So my relationship, my y equals kx, is y equals 15x. Remember that y is sales and x is people. So if it's 15 times people to get sales, that means that the 15 must be the cost of the ticket. So how many people attend if the sales are 15,000? Well, let's put that into this relationship. 15,000 is equal to 15x, and if you divide both sides by 15, you get that x is 1,000 people. So for the sales to be $15,000, 1,000 people have to attend. Here's number 2. Ounces of medication vary directly with the weight of the patient. Notice how it says varies directly, which means it follows the relationship y equals kx. And my two variables that I'm going to distinguish are ounces of meds and weight of the patient. The weight of the patient is the independent variable, and the ounces of meds is dependent on the weight of the patient. So weight is x and ounces is y. If a 120-pound patient requires 3/4 ounces of medication, how many ounces are required for a 200-pound adult? So first, I set up my ordered pair with my 120-pound adult requiring 3/4 ounces of medication to find my constant of variation. K, or slope, for a directly variated relationship is 3/4 over 120, or 3/4 divided by 120. 3/4 divided by 120 is the same as 3/4 times 1 over 20. Keep it, change it, flip it. 1 over 120, sorry. Keep it, change it, flip it, which if you do that computation, you get 1 over 160. That means that the ounces of meds is equal to 1/160th times the weight of the patient. So a doctor would take the weight of the patient, multiply it by 1/160th to get how much medicine they're going to receive. If we are looking for the dosage for a 200-pound adult, then we would be taking 1/160th and multiplying it by 200 to get the dosage, which is 5/4 of an ounce, or 5/4 ounce, not 5/4 of an ounce, 5/4 ounce. So hopefully you've seen how we do these problems. I want to divert your attention to numbers 3 and 4. In the first two examples, y was always the first variable and x was always the second one in the sentence. But be careful because that's not always the case. So let's look at number 3. Number 3 says the number of shares varies directly with the amount of dividends received per year. Well, amount of dividends is kind of like the money you get from owning stock. And the number of stock you own will determine how much money you make. So your number of stock is your X, and the money that you get from those stocks is your Y. It can't be the other way around, because this is the money that you earn from the stocks. So that's going to be determined by how much stock you actually have. So be careful there, because Y is not always first in the sentence. X could be first in the sentence, and Y could be second in the sentence. But that doesn't change how we do the problem. K is still Y over X, so if Kim owns 5 shares of stock and gets $12, my K is going to be 12 over 5. So my equation is Y equals 12/5 X. That's the relationship between shares and dividends. And if I want to receive $12 per year in dividends, I would be putting that 12 right here and solving for how many shares I would need. The same is true for number 4. In number 4, acreage varies directly with production of wheat. Acreage is how much land you have. So how much land you have, right? And how much land will determine how much you can produce, how much you can grow on your land. So this is going to be my Y, because how much I can produce needs to be dependent on how much land I even have to work with in the first place. So that's X. So in a 20-acre field, 300 bushels of wheat are produced. I would find my K by putting Y over X. So that's 15. And my relationship is Y equals 15X. That means for each acre, I can make 15 bushels of wheat. For every acre, I can make 15 bushels. At this rate, how many bushels will be produced in a 50-acre field? Well, we can change this we can change the X, that's the acreage, there we go. We can change the X into 50, and 50 acres times 15 will produce 750 bushels. So it should be pretty self-explanatory from here. Try 5 and 6, and let me know in class if you have any questions on these example problems. I will also post the answer key on Canvas. Thanks for watching.